Hello everyone, welcome to the channel Unknown Physicist. Today we are going to do a new topic in the paper Thermodynamics. This is a continuation of my previous video on first law of thermodynamics. If you have not watched that video, I am giving the link in the description. Please do watch it. So the topics we are going to cover today are second law of thermodynamics, reversible and irreversible process, heat engine. And our first topic is second law of thermodynamics. It's strange because it does not tell us what happens or what can be done, but it tells us what cannot be done. There are many scientists who has done experiments and given statements based on their understanding. Let us discuss the statement given by two prominent scientists. So the first statement is Clausius Tapir. It is impossible for a self-acting machine unaided by any external agency to transfer heat from a cold reservoir to a hot reservoir. Just look into the diagram. Here, look into the diagram. There cannot be any device that spontaneously delivers the energy from lower temperature to higher temperature. The work done is zero. But according to the Clausius statement, there cannot be a device with a work done zero. So in other words, heat cannot flow from a colder body to a hotter body. The working of a refrigerator or a heat pump is based on this statement. So the next is KelvinPlanck statement. It is impossible for an engine working during a cyclic process to extract heat from a reservoir and convert completely into work. So just look into the first figure. Here all the heat taken from the source Q1 is converted to work done completely and there is no heat rejected to sink. Whereas in the second figure, all the heat taken from the source is converted to partial amount of work done and little amount of heat energy is rejected to the sink. So 100% conversion of heat energy into work is not possible. That is, efficiency can be never equal to 1. 100% efficiency is not possible. So the working of a heat engine is based on this statement. That is, a perpetual machine doesn't exist, a machine with 100% efficiency. Our next topic, reversible process. A process which can be retraced back in the opposite direction in such a way that the system passes through the same state as in direct process and finally the system and the surrounding acquires the initial condition. Examples are fusion of ice, vaporization of water, gradual compression and extension of a spring. For example, here I have taken a mango juice in a tumbler. It is in liquid form. Now I am cooling it, I will get mango ice cream. But I want to drink mango juice. If you heat it, you will get it. So it is reversible process. You are retaining your initial condition. So it is a reversible process. There are many more examples. And the next is irreversible process. The process which cannot be easily retraced back in the opposite direction is called irreversible process. Example, work done against friction. For example, imagine you are hungry. So you have an egg. Now you are making an omelette with it. After some time you don't feel like eating. Will you get back your egg again? No, right? So this is an example for irreversible process. So this is about reversible and irreversible process. Our next topic is heat engine. So heat engine is a device used to convert heat energy into mechanical energy. So usually it is an exchange between two temperatures, between a higher temperature and a lower temperature. For conversion of heat into work with the help of a heat engine, the heat engine should contain the working substance which absorbs heat and does the work. That is, the reservoir from which the heat starts to flow is called source, and when some amount of heat energy is rejected, it is received by the sink. And always energy flows from a higher temperature to a lower temperature. For example, let us take a coffee cup filled with a hot coffee. So initially your coffee cup will be cold, but the coffee inside will be hot. So the heat will transfer from the higher temperature to a body which is low temperature. That is from the hot coffee to the cold coffee cup. Another example, let us take a balloon filled with air. Now I am making a hole in the balloon. The air from outer doesn't go inside, right? The air from inside comes out. So from higher pressure it comes to the lower pressure. Let us look into the working of an engine. Engine derives heat Q1 from the source and a part of this Q1 is converted into work and remaining Q2 is rejected to the sink to maintain an equilibrium. That is, the total heat is Q1 should be equal to work done plus Q2. So the work done by the engine will be equal to W is equal to Q1 minus Q2. Next is efficiency. Efficiency of the heat engine is the ratio of work done by the engine to the total heat supplied to the engine. So I am representing efficiency as neta. HE is for heat engine, which is equal to work done by Q1. Work done is nothing but Q1 minus Q2 by Q1. So it will be equal to 1 minus Q2 by Q1. That is also equal to 1 minus T2 by T1. And your efficiency is always less than 1 and it can be never equal to 1. That is possible only in ideal cases. So when you are subtracting some amount of fraction from unity, it should be obviously less than 1, right? That's it for the day, guys. So today we have looked what is second law of thermodynamics, reversible and irreversible process, heat engine and working of a heat engine. So in my next video, I'll be doing a Carnot cycle and how does a refrigerator works. So that's it. Keep practicing, keep revising the formulas. Bye bye everyone. Have a nice day.